Hello, in this video you will learn how to use PostgreSQL just to get started with Entity Framework, the setup, how you can install it and all that, sort of connection string setup and a bit about migrations. Now, if you are sort of familiar with Entity Framework, do sort of skip through it a bit. It's probably going to be about the same, almost exactly the same. There are a few tiny differences, but in the next video we'll take a look at the JSON-B structures, which is a sort of different thing, very useful thing as well for storing JSON in SQL database. So let's get started. The first thing we need is, of course, the NuGet packages, and then let's get into the setup for the actual database. The NuGet packages are quite straightforward. We have Npgsql.EntityFrameworkCore.PostgreSQL or PostgreSQL, and that's all you need, sort of. In terms of handling, at least compared to Entity Framework with SQL Server. This is your option in this case, but you still need the design part. This will help with the migrations and applying migrations and doing all that stuff. We'll set up the factories, we'll look at that later. The Open API part is just because we're using a bit of minimal API, and to help with that, nothing concerning the actual database. Now, for the setup, you can install it on your machine, but that's not really worth the time. It's best to get your Docker desktop ready, and then there you will be able to quite easily use a file such as this, Docker compose file, and then you can compose up. Now, do check out some of the other videos here. We have some caching arrangements. We use RabbitMQ in this sort of scenario of Docker, so it's quite a useful thing to have running on your computer, and it's relatively lightweight these days. But the actual setup, as you can see, we have just the image. The image, something to mention, once we get in these series into RAG arrangements, it will be a slightly different version of it, because we'll need that of vectorization setup, but that's something for another day. Just something, of course, to consider if you're going to production. If you actually need that or not, that will be a different image. But here we have the image itself, then we have the passwords, setups. Obviously, once you do install it, you'll probably want to change it, or depending how you actually deploy things, make sure it's not just simple secret 123 or something like that. Obviously, you don't want that laying around. And after that, you can set the volume. So the volumes you want to set in some nice safe place, right? Not a kind of a drive that will get wiped. So make sure that is done correctly, because you will be able to compose up and down, and the drive, the data will stay the same. So something to consider as well. It's not going to get deleted that way, but it can certainly quite easily disappear if mishandled. But that is your setup. Now, what we'll do, we'll create a little products table rather, and we'll have a few sort of properties in there. Nothing too fancy, just strings and dates, and then we'll try to retrieve that and create one, and more importantly, we'll try to run that initial migration so we can understand migrations a bit. So the whole structure of the database itself will be maintained from the code. So this is what's known as code first approach, essentially. We have all the table definitions as C# classes, and all these sort of other type definitions we'll have in a class, in a file called DbContext. In this case, we call it AddDbContext, but they are registered in a certain way, and you'll see that later. So the name can be whatever you want. Of course, you want to keep DbContext. So you might have products DbContext, you might have users DbContext, so you have a sort of separation. And then, of course, you can separate into different services and all that, and you get a sort of microservices arrangement. But we're not about architecture here, we just want to see the simple setup. So here we will need to define what is a products table. We do already have set up a little product class, just so we don't waste time on this tiny sort of arrangement. We have ID, name, price, stock, everything a normal default product would have. In the later videos, we'll try to continue on these the same databases to kind of improve on them and do some more complex arrangements, perhaps a bit of vectors and perhaps of JSON files. So it will be interesting to see that progression. Now, let's get back to the AddDbContext, the main context, as sort of default name. Again, you can name it whatever you want. But here, let's start with setting the table, right? So the table is what's known as DbSet. Now, of course, these days we do have those suggestions, so nothing, not much to do really, not much typing to do, and that's great. Of course, some of the other parts you will want to be very careful when it comes to suggestions. This is okay. We have our product, we have DbSet, that's the table. So DbSet is the table of type product. So whatever properties you have in that class, you'll have that in the database, and it will be able to sort of create those data types in the database accordingly, depending on what you have in C#. It works quite well these days. Again, it's certainly on the same level as SQL Server, so nothing to worry about. So we have products, that's what the table will be called, it will be called products. Now, there are some arrangements and you can play around more with customizing the names and things of that nature, but we won't get into that too much right now, just a little bit later. But let's set it up fully first. In order to actually make this work, we need to build the whole entity. So we need to create a sort of model builder for all the entities. Here we have a little suggestion, but we actually don't need all of this. You can certainly do that, what the suggestion suggests, I believe. But let's start with something a bit less than that. So a little override, void, and let's see, OnModelCreating. So when models are being built, and these DB sets essentially are being built. Now, it says OnModelCreating, really, perhaps it should be on DbSet creating, would be a bit clearer definition, at least on the surface, of what it actually does. So let's get rid of this, we will need that. But what we will need is the model builder. Okay, so we get to the entity and we get to the product, and this wants to preset some data or do something like that. Not very interesting. Let's just get to entity, product, and then we will only define those essentially columns of the table that we actually need to define, right? So we certainly don't need to mess with all of them because they will get constructed as integers, so we don't need to add any sort of min-max to them, character count or anything like that. However, let's open this up and actually let's close this and then let's do it like this. I believe that should work. Entity like this, like this, like this. Very nice. And let's expand that. So this will allow us to just modify certain properties or certain columns in the table, right? Those are matching in some way. Let's try to do something like property name, because property name will probably be required for the product. Let's take the suggestion, it will be easier. We have the name, it has to be required. So it's like setting in the database when you create a new column, you set is required. That's the same in code, and every time migration happens, it will make sure that it is the way it is required, right? If you remove that, you will need to run another migration. Again, we'll get to the migrations in a second. And of course, has max length. Now, as I mentioned previously, you certainly don't have to do that for everything, because if we look here, the ID, that's something that will be set automatically, although something to mention, you can also do GUIDs as well, as no problem with that, just like you can in SQL Server. you would just set it as a GUID type, and you would set up the sort of application on that. But we'll customize it a bit later. And another thing you can do on the price precision. So again, the same as you would have, say, decimal or something like that. So let's do quickly just to kind of see. Oh, it already gives us a suggestion, so that's great. The precision we certainly just kind of can go a little easier. This one will require for the price, which is a decimal, to actually be decimal 18 as column type. This is not probably the best way to do that, because as you can see, we have to use a sort of raw string. Now, using raw strings, you don't see an error. Things can go wrong. So actually, in this case, we can just simply do as precision, I believe. As precision like that. So after that, we just do 18 and 2, like that. So that's it. That's the setup. All we need to define in this part, sort of specific, database specific, really arrangement properties of a property we define here is required, all the lengths, precision and decimals, all kinds of things you can do, whatever is available in the actual database table. And that table will get created via migrations. But before we go to migrations, let's just take a look at some customization here. Now, sometimes you may want to have one name on property here on the DbSet and another name on the table. It might happen for whatever reason. So relatively straightforward approach here. On each entity that you are defining, you can simply do, let's see, entity to table like that, and then whatever name you want to name, let's say prods, maybe you want to name it, but usually we would have to do that, but you can certainly make those changes. So not just to properties in the table, but the table itself, there is some customization. One thing to get back to, for simplicity purposes, we're not doing GUID, but essentially the way it would work, and sometimes you quite often actually would want to do that, you would do GUID type here instead of the ID, and then here, let's see, where do we have it? The ID. There is a very special sort of arrangement, and instead of typing it in, I will sort of paste it in at some point. So we have has default SQL value. This will still be required, but we will have to define the ID. So going entity and then property ID. We can do this like that. Value generated on add, we can certainly do that. And there is a default setup. We're actually going to skip that, there's no point, but we do have this value generated on add, so that should work perfectly fine. Again, sometimes something to note, working with sort of older versions perhaps, or even new at some point, some of these things might change. So it's important to remember that once you set it up, you need to sort of be careful not to customize too much. That's always a mistake, because someone then in the future might have a very hard time actually sort of maintaining what you wrote if you customize it too much. If you have this sort of an arrangement, for example, I might as well just show you, because it can get a bit tricky. So you have essentially these custom arrangements, and that's not what we want. So this one I pasted, so it's kind of like putting it in the table, but who knows, maybe at some point it will be banned as an option, maybe it will be deprecated. So it's better just go with actual default method and not use this custom things. And the same goes for default values in all kinds of integers and decimals and doubles. Be a bit careful about that. But let's set it back to simple number ID, just for simplicity purposes in this case. And let's try to run a little migration, see how that works, see what file we get, and then we'll try to do a few queries. The migrations you can certainly run from PowerShell, but use the developer PowerShell in the Visual Studio. That way you are directly in the same project, in the same location, so it will be a lot easier. Now, what we have in this case, we have .NET EF migrations, and then we use add. This will add a migration. So when you have a DB set and you have some kind of a class there, in this case we have product, right? If you change something on product and then you add a new migration, it will automatically recognize there was a change in product compared to the previous migration. So it will apply that change in the database. Say we add a new column. Date updated. We have date created only. We'll need date updated. Okay, we add that. Then we'll need to run a new migration. In this case, we just run initial migration, so it will set up the table. In this case, we will set up the actual database. We'll create a database ourselves manually. That's probably usually a good idea because you want to sort of use different credentials for migrations and for actual database creation. And as far as applying the migrations, there are a few ways to go, but let's still look at the creating of a migration, because you need to create and then you need to apply it. So in this case, we call it initial migration, and then we say that it's in products API. This is what this example project is called, and also the context. Remember, I mentioned you can have multiple contexts. Also in your solution in Visual Studio, you may have multiple projects, so it's important to say which one. Another thing is if you have several projects that can actually start and use the database context, then you'll need to declare also like this startup project. So just write a startup project and the name of it. Something to mention because it can get sort of quite easy to get lost here, and the errors aren't usually self-explanatory. Another thing you'll need to install Entity Framework Tools. Here's a little script on how you can do that. Make sure it's the latest version, make sure all the versions are matching with the designer NuGet package. That's very important. So that is how the migrations are set up, at least from a sort of, shall we say, console perspective. Now let's get into the program.cs and see how they are actually sort of set up and applied, and what we actually need to access all that database context. Before we jump to the actual program.cs, there is this file. That's a file that was actually created in migrations folder, because you see we have a .ef migrations. That's a folder that will be created. You can name it something else when using the migration name, so it will be something / initial migration, for example. For different contexts it will sort of folderize it, but we have this new file created. If we look at it, you must never touch it. It's not for you to modify. It's there. It's handled via that console arrangement, but essentially, as you can see, it fully now defines the whole thing. If you want to customize something, you always do that via the AddDbContext on model building. That's where you actually do the customization. As you can see right here, we have identity column by default. That's generated, but then we have nullable false because that is required. That's what we set here. And then we have all the other arrangements as well, all the time zones. We'll get in time zones a bit later, perhaps in the next video. That's also an interesting topic for the databases. So here's what we have. Now let's move on to the actual program.cs. So in the startup, you'll need a couple of things just to be able to access the whole thing. We can go to app settings. Obviously, as far as app settings go, you should never expose it. This is just for demonstration purposes. The database name will be this, probably for this video, but we'll try to build on it later on. Again, it really doesn't matter what the database name is, because it's all handled via the code. So we just set it in the default connection string in this case. Well, in this case we have it named, so it's easier to recognize. And then you have your admin, your password, and you have your connection ready. Again, for security purposes, the ports should be locked with firewalls. That's probably the best way to kind of secure it from your application, most likely app service somewhere in Azure. This should be locked as well, wherever you have it hosted. So let's get back to the program.cs. Here, we'll first need to create a database context. And there are sort of a few ways to approach this. For the simple arrangement, in this case, we will just use a context, straightforward one. You can also use factory, which is better in some cases, but that's a matter for another video. In fact, it's probably better in most cases, but there is a bit more into that, so let's just kind of get started, and then we'll get into it in the later video a bit deeper. Let's do builder services, as we usually add all kinds of services here, and we use AddDbContext. This is basically our configuration. We can set this suggestion. There's not much to write here. The app DbContext is correct. That's the context we're using. If you have other ones, well, then you'll have other ones, and you'll name them accordingly and register them separately. So other than that, we use Npgsql right here. And then we get connection string, which, if you remember, was not what it says here. It was Postgres. That was the connection string. So now we have the context, and we have a way to actually access the whole thing. But after this, we still need to do the migration. There's two ways to do this. You can do it with the terminal as well, the PowerShell, to apply the migrations. However, for sort of development, and I would suggest for learning purposes, stick to this code approach that I will show you now. It's a bit easier and sort of less troublesome. Of course, for production, you'll probably want to do it in a pipeline, but again, that's a matter for another video. Let's just get through these sort of basics now. So let's do a little using, like that, so everything is properly handled. And I believe, again, with the magic of modern Visual Studio, we don't need to write too much. One thing to watch out with these suggestions, it's always great to take them because they are usually quite correct on these basic database setup arrangements. One thing to watch out, of course, is which context you're getting, and then back here, the actual connection string. You have a wrong connection string, you might get errors not connecting, something's wrong, not reachable, but it's just the wrong connection string. So something to really watch out for, and of course, which context you're actually playing around. If you have a few more in your project, it'll probably be quite easy to notice. If it doesn't migrate, it doesn't migrate. But this is how we can apply the migration in the code. We just get the context. It will look for existing and pending migrations in the project, and then it will apply them. Essentially, it creates records in the database which migrations are applied, it checks the code, and it applies all the pending migrations. So that's it. That's all you need to do. And again, in later videos, we'll get perhaps into pipelines a bit more, and how you can sort of create a context factory rather than a context. Something that you should do in production. The only difference will be just how you register it. Instead of AddDbContext, you add DbFactory, and then in each controller method or service method, wherever you're using the whole thing, you will not inject a context, but it will instead inject a factory, and it will get a context from the factory for that specific task. For simplistic purposes, we'll stick to context because there's going to be less code and it'll be easier to understand all the sort of queries that we'll be doing now. And with that said, we have a few more things to cover. We have a few queries to cover, of course, get some data, insert some data, perhaps update some data, the basic ones, but the most important ones. So let's get started, and we'll do it in a way of minimal API, nothing more than that. So let's start with inserting a product. Perhaps reading it and querying it and filtering it is a bit more interesting, and there's also something sort of memory perhaps related to think about. But let's start with inserting, because if we don't insert, we can't really do anything about it. And if you want to learn about minimal API separately, there are some videos on this channel specifically just covering minimal APIs, also specifically covering validation, and also security in minimal API. So watch all those three. They are quite short, and you'll be basically an expert in minimal APIs in .NET, but they are quite straightforward. So let's just do app. We do map. This is like controller route. Again, watch that video. It will be quite interesting, but basically it's just like a controller route the action method directly here. So let's map post like this, and then we'll have products, and then we'll have all the suggestion, and we don't need to play around with this. Now we're doing it step by step in this case. Probably we could just have an example to dissect, but in any case it's quite interesting to go along like this. We have a couple of things here. We have a product, right? And we have the DbContext. Now, this will come from the injected service, and this will come from the post request. The request body will be the product. And you could also have, say, ID as a parameter, as a query parameter. You'll see that a bit later in the retrieval part of the data. So here, after that, relatively simple arrangement, we're mapping to post. Then in order to add something, you need to add that DbSet type. Now that's where the mapping comes in. If you want to learn more about mapping specifically, there have been some changes in the world of mapping data recently, so take a look at the video we had a few weeks ago on this channel. Quite an interesting thing. You can certainly go with custom these days much faster, but there are some libraries. So essentially, if you have a different class for your post request or for your perhaps get request, you'll need to map it to DbSet, because you need to have a full sort of object of that DbSet type, and then you simply choose the table you have, the list, right? And then you add to it the DbSet product right here, and then you add. And then the most important thing, adding essentially doesn't really change anything. If you just do this and you leave, the database won't change at all. What changes the database is SaveChangesAsync. If I could actually show this, yeah, I can. So SaveChangesAsync, that's where the actual saving happens. So you can add multiple products like this, and only then do SaveChangesAsync, and they will all get saved at the same time. There's also SaveRangeAsync. Always use async. There's no reason to clog and block with the regular one. So we have AddRangeAsync. You can add multiple products with one. You can add and add and add, and then you must save. No matter which one you use, you must save changes. That's the most important thing. And then we just return the result that it was created. So again, that's a minimal API stuff. But as far as database goes, you add it like this. Take the context, find your table to which to add, use add or add range, and then save changes. Now, for error handling, Of course, we always want to go with a little try and catch, and you would probably do this in a service layer or somewhere else, not just like this, but usually something to sort of mention, if you put a breakpoint here and something is wrong, perhaps with a migration, perhaps with a setup, something isn't actually working, usually this first part will never throw an error. So if you want to look for exception, you'll be looking at the actual SaveChangesAsync. And SaveChangesAsync will apply for anything that's modifiable. So if you get a tracking list, you modify something, you update the product, you delete the product, then you use save changes for queries, so you do not need to save changes because you're not saving anything. So now let's look at how we can actually retrieve the data. For the retrieval part in this minimal API arrangement, we'll need to map get. Just quickly, let's do app map get like this. I think the suggestion is great. And this suggestion is quite interesting. So ToListAsync is something quite important, but essentially what we're doing here, we are getting the DbContext, we are accessing the products, but we are accessing at this point, the products is just a reference to the database. So we don't actually have it in memory yet, and we're not using any resources, we're not wasting any valuable sort of memory, right? That's very important. Of course, if you search for things, you'll need to search for it somehow, perhaps with where statements, perhaps with something else, all kinds of options you can have here. But something to mention, once you use ToListAsync, it goes into memory. So for example here, if we have, let's say, final products, a little filter we want to add, and this is the bad part, a sort of wrong arrangement, if you will. Let's do not like this, but let's say products. So now what we are doing, we are filtering, and this will work perfectly fine, but we are in memory. So we have all those products in memory. Now with 10, 100 products, of course, it doesn't matter at all. It won't probably affect performance a single noticeable bit. But with thousands, tens of thousands of products, you don't want to pull them into memory every time. So it's very important to actually apply this filter before you have ToListAsync, like this. Another thing that's important to kind of improve the memory a bit is do this, AsNoTracking, right? AsNoTracking, remember, so when you're receiving something, you don't need to modify it. You'll not think about modifying it. You're just receiving or retrieving rather the data, and you're sending it along to the user, to wherever. You want to always use AsNoTracking because it makes the sort of whole arrangement a little bit lighter. And of course, if you will want to modify, because you can find a certain product and modify it and then save it, this will save. But if you get that product's reference from DbContext AsNoTracking, you will not be able to save it. So it will essentially just fail to save. But if you're retrieving, you want to use AsNoTracking. And of course, then going further, you want to use where and select perhaps. So where will filter, will essentially have a filter, the same as in any sort of SQL arrangement, the where filter, and you can have all kinds of link arrangements in here. Essentially, we're using link. There are some tiny limitations, but nothing too much. And you can use, for example, something like max, so get the maximum value of something. And again, this part, all of this part is still happening on the database. You're not wasting your application memory. That's all great. Once it goes to ToListAsync, you're wasting application memory. It goes into memory, and again, you want to prevent that as much as possible. That's why it's important to have as much of that sort of relative, perhaps, data in one context, so you don't kind of mess with it. And something about the context I mentioned, we can have context factory, so in that case you would just have to create a context instead of just accessing it directly through the service layer. But this is this wouldn't be ToListAsync essentially because it's max, so we only get one value, but this would be ToListAsync products and then return the products, and then we can get rid of this. But again, no tracking, then your filters, and then ToListAsync. And if you modify without no tracking, you can do the SaveChangesAsync like we have here in the map post. For the purpose of this video, we will have a few more added to this, and there's a HTTP file, we can play around with it. It's available on Patreon. Do watch a minimal API course. It will be quite helpful and quite useful these days, especially if you're using something like Blazor and you want to set up a few webhooks. Very useful video, and we cover it all quite thoroughly. And for perhaps more of a front-end arrangement, take a look at some Blazor videos, some interesting things happening there in the latest versions, and MudBlazor for better UI, easier to build UI, and just a very good library in general for Blazor UI. Now, with that said, we're about to wrap up. The next video will be on JSONB, but we'll also look at the context factories and a few more advanced arrangements, but mainly we'll focus on the JSON B structures and sort of storing JSON data in PostgreSQL, which is very well set up for that. It's very good for it. So it's something really important to learn. And after that, in the probably third or fourth video, we'll get into vectorization, a sort of RAG arrangement. I'll explain how it works, how to set it up, and all those things. And with that said, we will conclude this video.